Our next lesson here is solving a right triangle. First, you know what it means to solve a right triangle. Solving means you know every angle and every side length. Not, you know the exact value for every side length, every angle. So the correct way to set up a triangle, the right angle is always going to be angle C. The other two angles, you should call them A and B, doesn't matter which one. Angles have capital letters, and angles will be capital letters. Opposite sides of each angle is lowercase. So if it's angle A, opposite side will be lowercase a. Angle B, opposite side, little b, and little c. Okay? That's the correct way to set up a right triangle. Our first example here, we've been given this information. B is equal to 5 and B is equal to 20 degrees. Well, notice the difference here. Little b equals 5 means the side length is 5, angle B is 20 degrees. So we draw a triangle. I usually always draw my triangle the same way, facing this direction. Right angle. This is going to be C, and let's go A, B. Okay. Side B, opposite of that angle, is 5. Big B, 20 degrees. Okay, to solve means we need to find all unknown information. Well, we know angle C is 90 degrees. We need to figure out what angle A is, what side length A is, and what side C is. Okay, well first, we know that all triangles have 180 degrees. This is 90 degrees, which means these two angles, A and B, are complementary. From geometry, they're complementary means they add to 90. If this is 20 degrees and these angles add to 90, this must be 70. Okay, that gives us more options determining side A and side C. Now, usually from here I just pick an angle I want to use. I know I need to solve for C and A. We do one at a time. Well, I know side A, angle A. I know angle A. I have the adjacent side. I want to find out the opposite side. I know angle A. I want the opposite side. I know the adjacent side. So you can think of a trig ratio that uses the opposite and the adjacent. It will be tangent. So the tangent of 70 degrees is equal to opposite over adjacent, A over 5. Okay. We want to solve for A. I'm going to clear out this fraction, multiply both sides by 5. Get 5 times the tangent of 7 degrees equals A. So, punch this in on your calculator. 7 degrees, not a special angle. You need a calculator. Make sure you're in degree mode on the calculator. There's two modes, degree and radians, in degrees. So you 5 times tangent of 70 degrees, and you should get, let's round to the tenths place, 13.7 is equal to A. Okay. Want to find side C now. Well, I could use angle A again and go sine. I go sine of 70 is opposite over hypotenuse, but I don't really want to do that because this is an approximation. It wasn't really 13.7, it was a lot of decimal places, but I rounded to 0.7. So if I use this answer again, I'm going to create an even bigger round off error. So I want to use a value that was given to me, exactly 5. So let's go cosine of 70. Cosine is adjacent over hypotenuse. Cosine 7 degrees is equal to adjacent, which is 5, over hypotenuse C. Okay. My variable's in the denominator, that's not good. Multiply both sides by C. So I got little c times cosine of 70 is equal to 5. Divide by cosine 70. Okay. Again, calculator, and you'll get C is about 14.6. And we're done. Next one here, the same thing. We're given two pieces of information. We're going to solve the triangle. So I'm going to draw my triangle. Right angle C. Let's call this A and B. Now, This one doesn't have to be A, this one could be A, this one could be, doesn't matter, but just I usually write it like that. 25 degrees for A. C is 4. This is little a, this is little b. Oh, I know these angles are complementary, they add to 90. See, 90 minus 25, that'd be 65. Okay, I need to find two pieces of information. Does not matter which order you go in. Let's see. I know this angle, 25 degrees, and I want the opposite side, and I have the hypotenuse. Opposite hypotenuse, that would be sine. Sine of 25 is equal to A over 4. Now, you did not have to do it that way. I could have done 65. I could have gone cosine of 65 is A over 4. Notice there, the sine of 25 is A over 4. Cosine of 65 is A over 4. Call it cosine and sine co-functions, same thing there. Okay, solve for A, multiply both sides by 4. And calculator, we'll see, calculator. 4 times the sine of 25. Need to be in degree mode. Oops. 4 sine 25. And we get 1.7. Alright, now we could do Pythagorean theorem to find a third side, but again, this is an approximation. It's a round off error. If I use Pythagorean theorem again, I'll get an even bigger round off error. So I'm going to use this value that I know is exact already. Let's go sine of 65 is opposite over hypotenuse. And I could have done cosine 25 here, but I like sine better. Sine of 65 is opposite over hypotenuse. So sine of 65 is equal to B over 4. Multiply both sides by 4. And calculator. 4 sine 65 to be 3.6. Last one here, a little bit different. The previous two examples we were given a side and an angle. This time we've been given two sides and no angles, but a different way to solve it. So let's draw our triangle. I don't know angles A or B. I do know that C, opposite of C, is 6. B, little b is, side B is 4. Here's A. Alright. Well, let's figure out one of these angles. Let's figure out what angle A is. Okay? So angle A is unknown, which means I need two side lengths that I do know in order to find angle A. I know the adjacent side of A, and I know the hypotenuse. Adjacent hypotenuse, that would be cosine. So if I go cosine of A, that will give me adjacent over hypotenuse 4 over 6, or 2/3. Okay. I'm solving for A. So now I need to eliminate the cosine or go the inverse cosine. Inverse cosine of both sides, which will just give me A is equal to the cosine inverse of 4 over 6. Inverse cosine. And you can do that on a calculator. Second cosine to give an angle, let's go 48.2 degrees. Okay. Next, let's go, since I did this is a round off error, okay, it's not perfect. I don't like to just, so 90 minus 48.2. Let's do some practice here and find angle B. Let's go. Inverse sine. I want to find the angle B. I know the opposite and the hypotenuse sine, so inverse sine. So sine of B is equal to 4 over 6. B is equal to the inverse sine of 4 over 6. And B will give us, make sure you're in degree mode, and you get 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. 41.8. Okay. Last part here, we need side A. Side A. Well, we could, like we did in these previous problems, use a trig ratio. We could go sine of 48.2 is a over 6, or tangent of 48.2 is a over 4, except this 48.2 is not exact, we round it. So if we use a rounded value to find our third side, we'll get an even bigger error. We don't want that. But these two side lengths are given to us and they're exact. If I go Pythagorean theorem, I'll get the exact value. A squared plus 4 squared, which is 16, is equal to 36. A squared is equal to 20. A is equal to square root of 20. Okay, square root of 20, that's radical 4 times radical 5. And that is equal to 2 rad 5. Okay, and there we are. Usually after this lesson, students usually like this one. They say, Mr. Kleins, these triangles in this trig class, they're all right. These triangles, they're all right. I say, yeah, I agree. These triangles are all right.